Good morning. Who is there online? Can you type your message? Okay. 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 Write down the question. In the circuit shown in figure, write the questions properly. Huh? This is all PYQ, means very important questions are there. In the circuit shown in the figure, comma, the initial key the initial key K1 is closed and key K2 is open, full stop. Then K1 is opened, then K1 is opened and K2 is closed So I will repeat this question. In the circuit shown in the figure, initially key K1 is closed and key K2 is open, then K1 is opened and K2 is closed. Then draw the circuit diagram. Here there is a battery and here actually capacitors are there. Okay, these are not batteries, these are capacitors. See, the lines are parallel to each other and their lengths are same, but here one terminal is greater in length and one is smaller in length. That means this is a battery. Okay, they only mention C1, C2, this is K1 and this is K2. This much is mentioned in the diagram and options are given here. Write down the options. Draw this diagram first. Draw this diagram. These all questions are very important. Actually, we are applying the concepts which we learned during the session. Finished? Then write down the option. Voltage across C1 equal to voltage across C2. Voltage across C1 is equal to voltage across C2. That is your first option. Then second option, voltage across C1 is greater than voltage across C2. Voltage across C1 is greater than voltage across C2 if C1 greater than C2. If C1 greater than C2. Then option C, charge on C1 charge on C1 equal to charge on C2. Charge on C2, and last option none of the above. Last option none of the above. I'll repeat all the options. Voltage across C1 is equal to voltage across C2. B option, voltage across C1 is greater than voltage across C2 if C1 greater than C2. Option C, charge on C1 is equal to charge on C2, and option D, none of the above. Okay, so here in the circuit C, initially key K1 is closed and K2 is open, and here देखो हम how I will explain, listen carefully. This is key K1 and this is key K2. Initially they opened this K2 and they closed K1. Okay, what will happen? If you turn on the battery supply, then current will flow through this branch. It's okay, it is obvious. And then in second case they kept this key open and they closed key 2. Okay, circuit is what getting disconnected here. Okay, so in both the cases anyhow current is flowing, but current is what getting divided, no? If I close this key, current is going to divide. So here no charge are same, because anyhow these two capacitors are connected in parallel. That means their voltages are same, but their charges, that means currents are not same, and current includes what? Charge. Okay, so we know that I is equal to Q by T, so Q will not be remain same, only voltage will remain same. Just they confused us, only they are closing first key and then they are keeping open second key, and then in second case they are closing key K2 and they are opening the key K1. But here always think, here two capacitors are connected in parallel, that means the potential drop across this C1 and C2 are remain same, they will not be changed. That all from the option, only correct option is option A. Can you getting this? How to apply the concept? Okay, here many things are given, people are thinking in different way, but if you observe properly, the two capacitors are connected in parallel. Very clear funda. Whenever there is a parallel combination, current is dividing, voltage will remain same. Okay, so option 1 is same. Option 1, that is A, is correct. Voltage drop across C1 equal to voltage drop across C2, that will remain same. This is the option, this is the answer. Can you getting this? Parth, Prakrut, and who is there? पार्थ, प्रकृत है, और कौन है? Okay, write down the next question. You can take the option A, then write down next question. Two capacitors of capacitance C of capacitance C are connected in series are in series, if one of them is filled with dielectric substance, if one of them is filled with dielectric substance K, dielectric substance K, dielectric substance K, what is the effective capacitance? What is the effective capacitance? Two capacitors of net capacitance C are connected in series if one of them is filled with dielectric substance K. What is the effective capacitance? So here, very clear question. Two capacitors are there, their capacitances are given, okay, C, and they both are connected in series. So according to the statements we can draw the diagram, okay. They are connected in a series, and moreover they are saying this capacitance is also C and this is also C. But the thing is that in one of the parallel plate capacitor they kept a dielectric medium. And is they mentioned dielectric medium? No. They only here dielectric medium is there. That means its capacitance will become K times of C. Correct? Because whenever we derive this relation, C dash is equal to Ck, or we can write here Cm is equal to K times of C naught. This we proved. Okay. So here one of the plate contain the medium, okay, dielectric medium, then its capacitance turns into K times of initial capacitance. Now they both are connected in series, means we know that we can calculate Cs is equal to 1 upon C1 plus 1 upon C2, correct? We did for parallel like this only, okay, and the capacitance of this capacitor is C plus capacitance of this medium dielectric medium capacitor is K times of C. Now simplify here Kc plus C divided by Kc square. So here we can take C common, K plus 1 upon Kc square, 1C and this C get cancelled. K plus 1 upon K is nothing but what? The 1 upon Cs. So therefore we can write Cs is equal to K upon K plus 1. Can you getting this? Okay. So this is 1 mark question. Copy this. Oh, 1C get cancelled. No, 1C will remain here. C and this is C. Getting this? Understood? Do you have any doubt? 2 are in series. So for capacitance we are taking 1 upon Cs is equal to 1 upon C1 plus 1 upon C2, and then substitute C1 capacitance is C and this is Kc. Take a cross multiplication or you can take LCM. Simplify. Answer we will get it in the form of 1 upon C. That you have to reciprocal. Then you will get the effective capacitance for these two capacitors. See, basic concepts are there. They are just twisting the questions. Getting? Prakrut, are you there? Partha, getting? Who is the third person? Copied everyone? Okay, write down the next question. Okay, write down the capacitance of a parallel plate capacitor. The capacitance of a parallel plate capacitor is 10 microfarad. Is 10 microfarad. When a dielectric plate is introduced, when a dielectric plate is introduced in between the plates, its potential becomes 1/4 of its original value. 1/4 of its original value. Full stop. What is the value of the dielectric constant of the plate introduced? I'll repeat. The capacitance of a parallel plate capacitor is 10 microfarad. When a dielectric plate is introduced in between the plates, its potential becomes 1/4 of its original value. What is the value of the dielectric constant of the plate introduced? Options are given. 4, first option 4, second option 40, third is 2.5, and D, none of the above. Then D, none of the above. So now can you try to solve this? Here the capacitance of the parallel plate is 10 microfarad. That is, C is given 10 microfarad. Okay, I will write down the given quantities here first. Then it is easy. The parallel capacitance of the parallel plate capacitor is, so C is given here 10 microfarad, and when a dielectric plate is introduced in between the plates, the potential becomes 1/4 of its original value. Suppose its original potential is V. Okay, and then whenever you are introducing a dielectric slab in between the parallel plates, then new potential is V dash, and what they are saying, it is reduces by 4, means it is reduces by 4 of its original value, correct? So they are saying its potential becomes 1/4 of the original value. 1/4 of the original value means 1/4 of original value of V, and of operator is there, that is multiplication. So 1/4 times of V, that means V/4. So new potential drop generated is nothing but V/4. And what they are asking here, what is the value of the dielectric constant in the plate introduced? It's very important question. Okay, so here we have the now original, means the potential when you apply the dielectric slab, we are getting V dash. Okay, but V is nothing but what? Q by C, no? correct? V is nothing but what? We have Q by C, and if we take another new potential as a V dash, then we will get Q by C. But here what will change? Here the new capacitance, if potential is generated, a new potential is generated by inserting the dielectric slab, that means here capacitance is also what? Gets changed. So original potential drop is nothing but Q by C, and here whatever the new potential drop is generated due to the application of dielectric slab, we are getting Q upon C dash, that is nothing but new potential drop. Now here we are interested to find out the value for K, that is dielectric constant. I have to find out. So how can you find out here the dielectric new K? Yes. And what kind of adjustment you can do here? Can you substitute here? See, we have V dash is equal to V by 4. V dash is nothing but Q by C dash, and V value is nothing but Q upon C, Q by 4 into C. But whenever you are introducing dielectric slab, that means this is K times of C dash, no? Correct? K times of what? The new capacitance. So can we cancel this Q and Q? This we will get this as 4C is equal to 4C dash. Can you getting this? Then capacitance, what we can do this capacitance? Yes. Can we take capacitances are same? No. Then what we can do here? Here already, yeah. Wait, what we can do here? Wait. Here we can do an adjustment. So V dash is nothing but what? Here we can write Q by C dash, and V is nothing but what? Q, and C is there, no? Then we can take this formula, C dash is equal to Ck or K times of C. So I will write here K times of C. Okay, can you getting this? And once you will get this, then what you can do? So Q get cancelled, but C dash and C will remains there. Okay, so C is nothing but Q by C. This Q by C, nothing but V. That means this V. Correct. So what are the substitutions we can do here? Q by C. If I keep that 4 as it is, or else 4, then V is equal to 4 times of V dash. So here we can write V is equal to 4 times of V dash is nothing but V by 4. But if we write V by 4, that already I took. That is V dash only. Yes, what kind of adjustment we can do? Or Q, or if we can write Q upon C dash is equal to that Q upon K dash by C. If I am writing like this also, yeah, this results into V by K. Yeah. Yeah, this is nothing but we can take it as V by K. That means Q upon C dash is equal to V by K. Okay, and V is nothing but we can take it as again Q by C. Yeah, yeah, yeah. Can you getting? You just copy this up to here. That is equal to Vk, and we will get here K value as a 4. Yeah, we are getting this. Yeah, you can copy up to here. And here Q by C dash is a V dash, and that is nothing but V by 4. Okay, so once you will get up to here, see the adjustments here, we will get here Q by C dash is equal to V by K, and here Q by C dash is nothing but your V dash. Okay, V dash is equal to V by K, and V dash is nothing but what? V by 4. So V by K, V will get cancelled, and therefore K is equal to what? 4. This is the answer. Little more adjustments. Immediately I didn't click the answer. So this is what the procedure. Okay. We have to apply little brain. Copy up to here. Finished. Next question. Sketch the graph to show. Sketch the graph to show how a charge capital Q. Sketch the graph to show how a charge capital Q required by a capacitor of capacitance C, capital C, varies with the increase in potential. So I will repeat this question. Sketch the graph to show charge Q acquired by a capacitor of capacitance C varies with increase in the potential difference. Okay. So we know that charge Q is directly proportional to the potential difference. At the beginning of this chapter or at the beginning of this potential, I told you, here also I wrote Q, what we can say that V is directly proportional to Q. Okay, so here see, V is directly proportional to Q, means this Q by C. Okay, and we can say that the charge Q is directly proportional. This charge Q is directly proportional to V from this equation. Okay, so Q is directly proportional to V. That means Q increases, then potential difference is also increases. Okay, and the resultant is nothing but what? Capacitor. So they are asking here to find out what? The capacitance. What is the value of a capacitance? So we know that here the capacitance, if we want to find out, okay, from here, if I want capacitance, C is equal to Q by V, because they are varying the charge and they are varying the potential. If both the quantities are changing continuously, then its resultant is nothing but what? C, capacitance, that is its slope. Okay, and here if we they are asking us to find out the sketch. Okay, so V, you can take it along the x-axis, and along the y-axis you can take Q, because slope is nothing but y by x, so y is a Q. and z x is nothing but v. So here see both the quantities are not varying directly. So v increases, then q is also increases, and you will get a straight line linear graph. Okay, so copy this. This everything should come while drawing this graph. Copy this. Calculate. Finished. Then next write down. Find the total charge stored. Find the total charge stored in the network of capacitors. Find the total charge stored in the network of capacitors connected between A and B. A and B as shown in figure. A and B as shown in figure. As shown in figure, and draw this figure. Okay. Draw this figure. This is plus minus 3 volt. Then 2, 3. This is terminal A and B. Okay, so they are asking us to find out the total charge stored on the network. Okay, so here check whether these are connected in parallel or series. Okay, and then according to that you can find out the answer. Okay, so this kind of questions are also very important. Okay, so now if you observe the diagram carefully, so this 3 microfarad and 6 microfarad are connected in series, and 4 microfarad and 2 microfarad are connected in series. So I will take this as a CS1 and this as a CS2. So first we can calculate here CS1. So here C1 upon CS1 is nothing but 1 upon C1 plus 1 upon C2. So this branch, this arm I am taking. So 1 upon 6 plus 1 upon 3, that is 1 plus 2 divided by 6. That is 3 by 6, that is 1 by 2. And here CS1 is nothing but 2 microfarad. Okay, this is what the answer for this arm. Can you getting this? Then you can go for this arm. Okay, so they are again connected in series. So 1 upon CS2 is equal to 1 upon C3 plus 1 upon C4. So 1 upon 4 plus 1 upon 2, that is again here 2, no, 3 by 4. So CS2 is nothing but what? 4 by 3 microfarad. Okay, this is what the answer. This is not a complete answer. This is what the steps I did. Now this diagram I will draw again in the reduced form. So here this equivalent capacitor CS2 is nothing but 4 by 3 microfarad, and this another, that is nothing but 2 microfarad. This is 2 microfarad. They are what? Connected in parallel now. And here we have the battery. For this parallel combination also you have to find out equivalent capacitor. Okay, so CP1 is equal to, you have to add 4 by 3 plus 2. That is nothing but 4 plus 6 divided by 3. Okay, so 4 plus 6 is 10 by 3. So 10 by 3 microfarad is the capacitor. So again I will reduce this diagram. Okay, try to draw the diagram, then only we will come to know that how much, up to how much point we can able to solve. So now this is 10 microfarad and this is how much? 3 volt is there. 3 volt. Now you can find out no charge. So we know that C is equal to Q by V, or charge Q is equal to C into V. So Q and equivalent capacitance is 10 by 3 microfarad into voltage is there 3 volt. Okay, so 3 get cancelled, 10 microcoulomb, because microfarad no 10 raised to minus 6. So 10 raised to minus 6 coulomb, that is 10 microcoulomb is what the answer. Okay. Calculate this. Understood how to solve this kind of question? These are very important. Mostly they will ask for 2-3 marks. You must have to analyze the circuit. Okay, write down next question. You are given three capacitors of 2 microfarad. You are given 3 capacitors of 2 microfarad, 3 microfarad and 4 microfarad respectively. You are given 3 capacitors of 2 microfarad, 3 microfarad and 4 microfarad respectively. Full stop. First, form a combination of all these capacitors. Form a combination of all these capacitors of equivalent capacitance 13 by 3 microfarad, 13 by 3 microfarad. Okay, full stop. Second bit, what is the maximum and minimum value? What is the maximum and minimum value of the equivalent capacitance that can be obtained by connecting these capacitors. Okay, this you have to do it as a homework. Okay, this is already we did. So it's very clear, my minimum and maximum. So here maximum is nothing but parallel combination and minimum is a series combination. So you have to arrange that and you have to calculate that. Okay, now next question. Write down. Yeah. Find the ratio of the potential. Find the ratio of the potential differences. Find the ratio of the potential differences that must be applied. That must be applied across the parallel and series combination of two capacitors C1 and C2 with their capacitances in the ratio 1:2 so that the energy stored in the two cases becomes same. So that the energy stored in the two cases becomes same. I will repeat this. The ratio of potential differences that must be applied across the parallel and series combination of two capacitors C1 and C2 with their capacitances in the ratio 1:2. Then 1:2 so that the energy stored in the two cases will become same. Okay, so now what we have to do, check. Okay, so energy in the capacitors, we derive the relation for energy in the capacitors. So here if you learn the derivations and you know that, then only you can able to solve this kind of questions. So now here we know that energy in the capacitor U is equal to half CV square, or you can write E is equal to half CV square. And now here they are giving two capacitances, and the two capacitances are C1 and C2, and they are connected in parallel and series. Okay, so I will write for series. So half C series and V in series. Can I write it like this? Okay. And similarly for parallel combination, we can write half Cp and Vp square. Okay. And now what they are saying, whenever these two are connecting in combinations, their capacitances ratio is 1/2, so their energy stored in the both cases becomes same. Okay, the combination of C1 C2, their capacitances are in the ratio. Okay, so here their capacitors are in the ratio of 1/2. Then now what we can do here, there they are saying their energies are same. Cp is equal, Ep is equal to Es. Energies are same, they are saying, and then Ep is nothing but what, half Cp square, and Vp square is equal to half CS square and VS square. See, half and half get cancelled. Okay, and if we they are saying capacitances ratio, sorry, potential drop ratio they want. Okay, so their capacitances are in this ratio, and then can I take here V series square, and Vp you can transpose to that side, and here you will get Cp, Cv square, not Cp square, yeah. So here Cp divided by what? You will get Cs. Okay. Now if I take a square root on both the sides, so this is Vs upon Vp is equal to square root of Cp upon Cs. Can you getting this? This is what I am getting the equation. But now the problem is that Cp, here two capacitors are there. Cp, they are connected in series. Cp is a parallel combination. 1 upon Cp is nothing but 1 upon C1 plus 1 upon C2, that is equal to C2 plus C1 upon C1 C2. Okay, this is 1 by Cp. Then Cp we can write it as C1 C2 upon C1 plus C2. Can you getting? And Cs is nothing but what? We can write only C1 plus C. Oh, sorry. So this is not Cp. This is Cs. Here we are taking ulta combination. Okay, and in parallel combination we can write C1 by C2. Now here ratio is there Cp by Cs. So I will write here Cp by Cs. Okay, so Cp is nothing but C1 plus C2 divided by Cs is nothing but we have here C1 C2 divided by C1 plus C2. Now do this reciprocal, C1 plus C2, and this is also goes up, C1 plus C2 divided by, we have a C1 plus C2. Can you getting this? Cp by Cs I am getting. Now one more thing we can do, Cp by Cs is nothing but, you can, brackets are same, their powers are get added, so you can write C1 plus C2 whole bracket square upon C1 plus C2. Can you getting this? But I don't want Cp by Cs, that should come into the root. So we have to substitute in this root value. Okay, so I will do it here. So Vs by Vp is equal to, I will write here C1 plus C2 whole bracket square upon, I have here in the denominator C1 into C2. Sorry, here I made a mistake. C1 into C2. This square and this root only for this bracket is get cancelled, and you will get C1 plus C2 divided by root, this is nothing but C1 plus C2. C1 root of C1 C2. This is nothing but what? The potential drop you are getting. Okay, but they are saying the capacitances are in the ratio of 1:2. Okay, 1:2 means here 1 by 2. So this is 1 plus 2 is a 3 divided by 1 into 2, that is nothing but root 2. So answer you will get it as root 3, sorry 3 by root 2 is the answer, because they are saying C1 is 1 and C2 is equal to 2. Getting this? So copy this. Is all 3-mark question, very important questions. You can practice right after this session. Okay, finished. Write down the next question. A parallel plate capacitor, of capacitance C is charged to a potential V it is then connected to another uncharged capacitor. It is then connected to another uncharged capacitor having the same capacitance full stop. Find out the ratio of energy stored in the combined system to that of stored initially in the single capacitor. Again, I will repeat this. A parallel plate capacitor of capacitance C is charged to a potential V. It is then connected to another uncharged capacitor having the same capacitance. Find out the ratio of energy stored in the combined system to that of stored initially in the single capacitor. Okay, so here the parallel plate capacitance C is given and whose potential is V is also given. Okay, and that is connected to another uncharged capacitor having the same capacitance, means both are having capacitances are C1 and C2. Charged capacitor is also having capacitance C and uncharged capacitor is also having capacitance C over here. Now once these two are connected in the they are saying connected to uncharged having the same capacitance, find out the energy ratio stored in the combined system to find out that stored initially in the single capacitor. Okay, so normally for energy we have energy stored in the capacitor, we have half CV square, and other two expression just we calculated by putting the value C is equal to Q by V and V is equal to QV. So that formulas we did and there we got half QC square, correct? We got half Q square C. This formula also we got there. Okay, so I think we did three different combinations for energy. Once we get half CV square, then we are substituting value C is equal to QV and V is equal to QC. That formula we can find out and then we can substitute the values and we will get half Q square C. This formula I am getting. Now what they are saying here, when the both charge means here what these two are the capacitors. Okay, so these both are having same capacitance, or suppose they are not connected initially. Now they both different capacitors, their capacitances are same. But suppose when they are connected in series, they are connected in series. If they are connected in series, what is the combination? 1 upon series is equal to 1 upon C plus 1 upon C. That is nothing but how much? 2 upon, we can get 2C upon C square. That is 1 upon CS. So therefore, we will get it as CS is equal to C by 2. This is nothing but what we are getting the capacitance whenever they are connected in series. Suppose if they are connected in parallel. Okay, they are connected in parallel, then Cp is equal to C plus C, that is equal to 2C. This much is what the capacitance we are getting in a series combination. But what they are saying here, they are combining. Okay, they are parallel plate capacitor connected in another uncharged coupler, same capacitance. Find out the ratio of the energy stored in the combined system. Okay, so that stored initially in the single capacitor. Okay. Now here problem is that how much is the initial energy. So apart from this combination, what is the initial charge, the initial energy they are possessing? Initial energy is even only, no, that is nothing but Q square by C we have. That is Q square by C, initial energy. And then here final energy is nothing but you can take EF. Okay. So now final energy, they did not clearly mention which combination is this, whether this is parallel or the series. We don't know here whether they are connecting in parallel or series. But for our convenience, I can take the parallel combination. If suppose these two capacitors are connected parallelly, then their final energy stored is nothing but what? Q square, and here total capacitance is 2C. Now they are asking, take a ratio of initial energy to the final energy, that is Q square by C divided by Q square by 2C. So you will get Q square by C into 2C divided by Q square. Q square, C get cancelled, and I will get the answer 2 by 1. Okay. And if they are asking final to initial, then it will come 1 by 2. Can you getting this? So this is also 3-mark question. Here they didn't mention clearly whether this is in the parallel or series. For my convenience, I took parallel. If you want, you can take the in series and find out. You will get some different answer. Understood here? Copy this. Oh, this is initial is Q square by C. This is 2 is there, no, sorry. And here 2 into 2 because this is 2C. Yeah. And then here it will come 2 and here it will come 4. Yeah, answer is 2 by 1 only. Yeah. 2 2s are 4. Yeah. Copy this. Here also it comes 2C and here 4C. हो गया? Write down one more question. This is also IMP question. The given graph shows variation. The given graph shows the variation . The given graph shows variation of charge Q. The given graph shows the variation of charge Q versus potential difference V for two capacitors C1 and C2. Full stop. Both the capacitors have same plate separation. Both the capacitors have the same plate separation. But plate area of C2 is greater than that of C1. Which line A or B corresponds to C1? Which line A or B corresponds to C1 and Y? C1 and Y. Then next line. Okay, I will repeat this. The given graph shows variation of charge Q versus potential difference V for two capacitors C1 and C2. Both the capacitors have same plate separation, but plate area of C2 is greater than that of C1. Which line represents A or B corresponds to C1 and Y? Okay, and the graph is given in many exams. They are asking this kind of question. They are sometimes asking for C1 and sometimes they are asking for C2. Okay, logic behind both the questions will always remain same. So this is V and this is they took a charge. Okay, so here they gave two graphs. I will explain both the questions. So this is B and this is A. Okay, so here what they are saying, we don't know here which one is C1 and which is C2. So obviously A and B. So here if you take a slope for line A, so slope of A is always greater than slope of B, because B is little towards the potential drop, means towards the x-axis. So its slope of B is always smaller. So slope is greater and smaller means what? This is a graph versus Q by V. We know that Q by V is nothing but C. So whose slope is greater, their capacitance is also greater. So this is capacitance C1 because this is having a greater value of slope. So capacitor C1 is greater and this is nothing but what? I am taking C2 whose capacitance is smaller than the C1. Okay. Now what they are asking in the question? So they are asking which lines corresponds to C1 and why. So C1 corresponds to what here? Is they mentioned C1 and C2? Yeah. Here the plate separation, plate area C2 is greater than C1. Which line corresponds to C1? Yeah. Which line corresponds to C1? So line B corresponds to C1 they are asking, no? Okay. Here C1 shows that A. Okay. So A line whose slope is more. Okay. And B is what? Having slope less. That means its capacitance is less. Can you getting this? Yeah. Because plate area of C2 is greater. Separation is more. Okay. They are asking this separation is what? More here. Okay. This D, suppose if I am taking this as a C1, this also we can analyze. C1 and this is C2. This is greater in first and this is little bit smaller. I will take this as a capital, this as a small t. So here we know that C is equal to epsilon A divided by D, and C2 is nothing but epsilon, this D will become capital D, epsilon A divided by small d. And what they are saying, the separation between the plate C2 is greater than of C1, yeah, A and B, which of the corresponds to C1. Yeah, it's correct. Can you getting this? So here slope of line B is lesser than that of C1. Okay. So here C1 represents line A and C2 represents line B, because C2 is having less capacitance. Okay. Because more is the separation, then less is the capacitance value, and less is the capacitance, less is the separation, then capacitance is more here. Okay, so according to the slope I am getting this A1, means the slope of A1 is greater and slope of B2 is smaller, but if we compare the distances, means based on the separation if we are writing, then C1 is having what, the T, means the separation is more, then capacitance of C1 is also what, decreases. Capacitance of C1 is decreases as D is what, increases, or D is greater here. And in second case C2 is what, increased, because small d is what, reduces, means that small d is nothing but having smaller value. Okay, so if they are asking explanation based on the distances, then you can say that the capacitance of C2 is greater than C1 if the with respect to the plate separation, and depending upon the slope C1 is greater. Okay, so here they are asking for separation, then C1 we can say that B is lesser than the line A. That's it. Understood? C1 represents A and C2 represents B. Copy this. Okay, I will end this session.